Everyone, welcome to Master the Codes, and today we are going to take another important question related to Amazon interviews, that is the binary tree. I will explain two approaches. First one is a DFS approach and second one is a BFS approach. So please do not forget to like, share and subscribe to the channel for more notifications. Without further wait, let's get. So here's the question which we are going to solve today, that is diameter of a binary tree. Although it is marked as easy, it is not an easy question and is quite commonly asked in an interviews in the companies like Amazon, Facebook, Microsoft, TCS, and many more. This is one of the standard questions. So now let us ace this particular question and so on the coding interviews. But before that, please do not forget to like, share, and subscribe to the channel. Now let's move forward. Given the root of a binary tree, return the length of the diameter of a tree. Okay. Now, first thing is we are given a binary tree, so we are either gonna have no children, or we are gonna have one children, or we are gonna have two children as the root from the root nodes or any other node. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. So it's clearly mentioned in the question. The length of a path between two nodes is represented by the number of edges between them. So if I'm taking this particular path, if the number of nodes are 4, the edges will be 4 minus 1. That is what it is. Now coming to the question, the root is 1, 2, 3, 4, 5. The output is 3. And 3 is the length of the path. Either it is 4, 2, 1, 3 or 5, 2, 1, 3. That is one and the same thing. Now let's move on to the first approach. I have solved this using two approaches. You can take any of them, right? So I'm taking the first approach and then we are gonna go for the second approach as well. Okay, now coming to the second approach of finding the diameter of a tree. In this particular approach, we are going to take an undirected graph or an undirected tree where from root to parent and parent to root, the traversal is always possible. If you haven't checked out the first approach, I have shared the link in the description down below as well for you to check. And please do not forget to like, share, and subscribe to the channel. Now, in this particular case, what we are going to do is perform a two-pass BFS to evaluate the maximum distance or diameter of the tree. Okay, so from here, we'll do a BFS. Let's say we'll go to nodes 2 and 5. Then from 2, we'll go to node 3 and 4, and 5 will go to node 6. Such that what will happen? The depth of these two is same, and the depth of these three nodes is same, right? As you can see over here, this depth is 1, this depth is 2, and this depth is 3. Now among these three nodes, we are gonna store any one of the node and return it. Okay, so here the node is 4, let's say. Now what will happen? From node 4, we will start with a second BFS. Now it will go to node 2, that is of depth 2. Then it will go to node 1, that is of depth 3, and to node 5. Then to node 3, that is of depth 4, and then to node 6, that is of depth 5. And so from here to here will be a total depth of 5, and we'll get a result in a 2 pass. So if you look at the time complexity, it will be order of n for time and order of n for space if you are taking no extra memory, because you're passing n nodes, so that means the tree is of size order of n, or if you consider only the auxiliary space, that is order of 1. So that is the second approach. It is quite easy. The only thing is the tree should be undirected, right? The tree should be undirected. In case of it is directed, if the tree is given directed, you need to convert it to undirected. Now how to convert it, I'll explain it in the next video. So that, or rather if I say it, put it simply, from tree you need to convert it into a graph with a root node. So, and then you can perform a BFS or DFS. Then it would be a bit of long procedure because from tree you are gonna convert into graph, and then from graph you're gonna perform a two-pass BFS again. So it is a long procedure. Usually, first approach is preferred, but this is also approach which you can try to perform if you are just asked in how many ways you can evaluate the diameter of a binary tree. So now, without further waits, let's jump into the coding section. So here is the second approach where we use a two-pass BFS to evaluate. So I'm passing the tree and the root. In the result array, I will store the deepmost node, right? The deepest node using BFS. It is works similar to DFS. The only difference it uses queue instead of a stack. And now in this output array, what I'm gonna store? I'm gonna store the deepmost node, the deepest node, and the depth of the node. Okay. So I'll use the queue, add the current root, that is 1 most probably, into the queue, perform the operation, check for the left child and the right child, and then increase the depth, and then output of 0 will become the depth of the current node. And then the output of 0 will become the first element in the output array will be the node itself, and the second element in the output array will be the depth of the node. Then I'll use the DFS again, or the BFS again, and from this time I'm not gonna use this root, the initial root, that is 1. I'm not gonna use this root. I'm gonna use the deepest node that I have found and start the BFS from there. So what will happen in that case, it will go to the next farthest node, and that will definitely give us the depth of the tree. And then we are going to print the second element in the output array or the result array, that is the depth of the node. So that is the second approach. It uses a two pass, so order of 2n, that will again give us an order of n complexity, and that is how you can perform the operation. Otherwise, if you want to do in a single pass, you need to use this post order traversal. I'll post both of these codes in the link down below, as well as the GitHub repo where you can find all other interview questions asked by Amazon. So please do not forget to like, share, and subscribe to the channel. And in case of notifications, hit the bell icon. Until then, bye bye.